Hello there, Algebra 2 students. This is Mr. Kashi speaking. This video is going to be going over our day 3 of stats on normal distribution. So the first slide here is just kind of our schedule for today. If attendance hasn't been taken, hopefully we can get that going as soon as we can. We're going to take notes on stats, and I do have a worksheet for you later on as well. So our class objective is by the end of class, I will be able to recognize a normal curve and be able to calculate probabilities using the curve. So we're going to be talking about normal distribution today, and this is something that is used in quite a bit of different areas and different jobs. So statistics day 3, normal distribution. First key point we're going to talk about is the uniform distribution. You should have a copy of these notes, and so I'm not going to spend too much time because you're not going to need to write that key point in. But normal or uniform distribution just means that the data points in a set are spread out evenly from the mean, and what they make is they make this this type of curve. We call it a normal distribution, or sometimes it's called a bell curve. So as you can see, it's shaped like a bell, and so they call it a bell curve. And something that's very important is that it's symmetrical. Okay, so here it's these two are just general bell curves that you can see that the majority of the people are in the middle, and there's very few people out at the extremes there, and we're going to be talking about how this fits into a normal curve. Or sometimes they split them up into performers. Your high performers are off to the right, not as many as your average performers. Those are all in the middle, and then your low performers down to the left there in the other graph. Okay, so normal distribution. Normal distribution is it's a curve, and this is a set of data points, and they're all evenly distributed. And what does this all mean? Well, normal distribution is talking about the mean and standard deviation. And so the mean and standard deviation will create the following areas under a normal curve. And we're going to talk about those different areas here, and we're going to fill up this normal curve with the different percentages. If you need to pause the video to write those notes down, go ahead, but I do need to move on here. So we're going to start on the bottom, and right here, this middle point, that's going to be our mean right there, our average of all of our data, and that is going to be, obviously, a lot of our data is going to be pretty close to the mean in a normal distribution. And then all these points here, we have, this is adding 1 standard deviation to the mean. This is adding 2 standard deviations to the mean, adding 3 standard deviations to the mean, and we actually have a 4th as well. So add a 4th standard deviation. That's getting way out to the right. And then we also have the other direction. Obviously, we have taking 1 standard deviation off the mean, and so on and so forth. So this is -2, this is -3, and we are going to have a 4th way off to the left. Okay, and this is kind of getting back to some probabilities and things like that we're going to be talking about. But obviously you can see this this large area in the middle here that is right around the mean, and we'll talk about some very common things that happen with normal means here on the normal distributions here on the next slide. But I do want to go through and say what the probability is of falling in these certain areas. So right here, between the mean and adding 1 standard deviation, there's a 34% of our data points are going to fall in that. And like I said before, this is very symmetrical. So if there's if it's 34% between the mean and adding 1 standard deviation, it's also going to be 34% subtracting 1 standard deviation. So that is the majority of our data points are going to be in between, or going to be within 1 standard deviation here. So 68%, if you wanted to add those together, 68% fall in between subtracting one standard deviation and adding another standard deviation. And if we go another standard deviation out here, this would be 13.5%. Once again, it's symmetrical, so over here this would all be 13.5% as well. Then we get pretty small. So in between 2 and 3 standard deviations, this would be 2.35%, and this here is also 2.35%. And then getting out to 4 standard deviations is very, very minimal, and that area you basically can't even see on here. That is actually 0.15%. And out here that is 0.15% as well. Okay, so that is how our data points are distributed, obviously with the majority being in the middle and getting very, very rare as we go out to the right and to the left. We're going to be using this normal distribution to start talking about specific data. And instead of having across the bottom here having the mean and plus 1 standard deviation plus 2 standard deviations, we will have actual numbers there. So just to kind of talk about these areas as a whole, the next slide is talking about your high performers, your average performers, your poor performers, if you're talking about performers in a way, and just that area in the middle is usually a pretty big majority. So 68% of the performers, which is the majority, are within 1 standard deviation away from the mean, and that's that 68% right in the middle there. So taking the 34 and the 34, adding them together. So across the bottom here you can see that, like, whatever this data is, this 100 would be the mean. Then our standard deviation would be 15, and so we have to add 15 going to the right, subtract 15 going to the left. And so what we are saying is that 68% of our data points are between 85 and 115. And then we keep going, and these are rounded percentage values. Okay, so that might be something that you want to go over here. Say this is just some generalization that we're talking about here. See how they use 14% instead of our 13.5, and they use 2% instead of our 2.35. They've rounded these just to kind of help us get some a general understanding of how these groupings work. All right, so we're going to go do some examples here, and we're going to create one normal distribution curve, and then we're going to answer some questions about some probabilities of falling in those different areas that we just defined. So the results from a chapter test show a normal distribution. The mean test score was 78, and the standard deviation was 6. So the first thing that we need to do is we need to draw our horizontal axis, and then we basically just need to create a nice even normal distribution curve. Okay, and then we'll start right in the middle. Our mean would be 78. Okay, and we can draw a little bit of maybe a dotted line there. And then what we have to do is our standard deviation is 6. Okay, and so that is how much we're going to be adding on. So if we add 1 standard deviation, 78 plus 6, that gives us 84. So our first standard deviation, that's right here, that's 84. And if we were to go 1 more standard deviation further, that would be 84 plus another 6, that would be 90. And then keep going, we'd have 96. And then now you can kind of see why this fourth standard deviation out there is rather small, because, well, it's 102, and that'd be over 100. And if this is percentage scores, that would be rather hard to get anything over 102, which is that 0.15%, which is not very likely. We have to do the same thing going the other direction. So 78. So these are all the scores above 78. We're talking now. We have to move over, do the scores below 78. So instead of adding 6, we're going to subtract 6. So 78 minus 6 would give us 72. Then another standard deviation, 72 minus 6, that would give us 66. Another one would be 60. And then finally, we have 54. Okay, and then you could write these different probabilities in, right? So we have the 34% here and the 34% here. This might help us a little bit later with these problems. And then this would be our 13.5%, and this would be our 2.35%, and this would be our 0.15%. Okay, going the other direction, this is symmetrical once again. So this would be the 13.5, that would be the 2.35%, and the 0.15%. So if we have this normal distribution, the majority of us, the 68% of us, had a score between 72 and 84. That's just a general, and look at that. It's pretty close to that same question here for B. So what is the probability that a randomly selected test score is between 72 and 78? Well, between 72 and 78, we've already recorded that percentage in there, and we just can rewrite that down here as 34%. Okay, then moving on, what is the probability that a randomly selected test score is greater than 90? Well, if we're talking about greater than 90, we're looking up here at 90 and then everything this way. And so in between that 90 and 96, that percentage would be 2.35%. And then we would have to add the 0.15%. And if we add those together, we get 2.5%. So to have what's the probability of getting a score greater than 90? 2.5%. That's not very likely in the grand scheme of things here. All right, and then we're just going to go over D. We can go over E at a later time. What is the probability that a randomly selected test score is between 60 and 66? Well, that is just recorded for us. We already wrote that in. That is the 2.35%. That is on the other side of the mean. That's down at the lower point. We will get to E here in class. That has a handful more steps, and that's kind of taking these concepts a little bit further and really using some of the probability concepts that we've already learned in class. So you'll be having a handful of different examples like this on your homework to practice on. Obviously not just with test scores, but they'll be using different data sets with bigger numbers, smaller numbers, and that will be on your stats review worksheet number 2 that you can start working on after notes have been completed. If you do need to obviously rewind or rewrite any of the notes, feel free to do that, but I will see you soon.